Negative catalyst. We stop at a negative catalyst. Negative catalyst. A negative catalyst. A negative catalyst is a catalyst. Is a catalyst that lowers the rate of chemical reactions by increasing the activation energy activation energy is the minimum energy required for a chemical reaction to occur, and the function of a normal catalyst, positive catalyst, is to increase it, is to lower it. Once it is lowered, then the time taken for reaction will be reduced. The negative catalyst will rather lower the rate of chemical reactions by increasing the activation energy. A very good example is in the preparation of oxygen from hydrogen peroxide, decomposition of hydrogen peroxide, where we have water. This one is composed of water and oxygen. If you balance the equation, you have the equation balanced this way. So we use A3PO4 used as a negative catalyst to lower the production of decomposition of hydrogen peroxide. In this case, it acts as a negative catalyst. That is negative catalyst. We are done with the first classification. Another classification, we call it homogeneous catalysis. Homogeneous catalysis. Many types of catalyzed reactions were homogeneous catalysis. This is a type of catalyzed reaction. It's a type of catalyzed reaction where the reactant, product, and the catalyst itself, where the three are in the same phase, meaning the same physical state. We call it homogeneous. The word homo in science means the same. A very good example is where we have SO2 gas plus oxygen gas. So that's all four that plus oxygen gas to form SO3 gas, where you balance the equation, and NO, nitrogen 2 oxide, is used as a catalyst. Is a gas. You can see that SO2 is a gas, oxygen is a gas. These are the reactants. The product, sulfur 6 oil, is also a gas, while the reactant is also what? A gas. So they are in the same physical state. We call it homogeneous catalysis. But heterogeneous catalysis. Heterogeneous catalysis. This is a catalyzed reaction where the reactants, the products, and the catalyst itself are in different phases, meaning they are in different physical states. Where we use KCNO3 3. Solid. We use manganese 4 oxide as a catalyst. Solid. We use KCl. Solid. Then oxygen, gas. They are in different states. So this is a heterogeneous catalysis. That is 1. 2. Let's talk of ammonia. Haber process. Ammonia. Manufacturing of ammonia. Haber process. If I put 2 here, 3 is here. Where iron, finely divided iron, is solid. You can see this is solid. This is a gas. They are in different phases. So this is known as a heterogeneous catalysis, and so on and so forth. In this reaction also, SO3 gas, if you balance the equation 2 here, state of matter is gas, this is also gas. But if you now use vanadium 5 oxide, which is a solid, this will be categorized under heterogeneous catalysis, and so on and so forth. So these are some of the catalysts we have. Another one, they are not catalysts per se. We have promoters. They are not catalysts. Promoters and inhibitors. They are not catalysts per se. Like promoters and inhibitors are not catalysts, but they influence the rate of chemical reactions by affecting the efficiency of the catalyst. So in case of promoters, it activates the rate, the rate of chemical reaction by a catalyst. It activates the rate of chemical reaction by a catalyst. E.g., in the production in KClO3, in the preparation of oxygen, thermal decomposition plus KCl, you can balance the equation. 2 here, 2 here, 3 here, equation is balanced. This is here, manganese 4 oxide is used as catalyst, but we normally add aluminum oxide and or molybdenum. The function of aluminum oxide, which is first of all added, is to activate manganese 4 oxide. So aluminum, small quantity of aluminum oxide is added to activate manganese 4 oxide. So here, aluminum oxide serves as a promoter. It's not a catalyst, but a promoter. It activates the manganese 4 oxide. That's what we call promoters. They are called promoters. We have inhibitors or Inhibitors. Inhibitors are catalyst poisons. Are catalyst poison that kills. They are catalyst poison that kill or render the catalyst inactive. They make them inactive. They are called inhibitors or catalyst poison. They are catalyst poison that kill or render the catalyst inactive. They are called inhibitors. E.g., let's see the following in the body. They lower the activities of or they kill or they render the activity of some enzymes in human body inactive. E.g., one, we talk of arsenic 3 oxide. Arsenic 3 oxide is a negative, is an inhibitor. Arsenic 3 oxide. We talk of hydrogen sulfide. Hydrogen sulfide is also there. Hydrogen sulfide is there. Hydrogen cyanide. Hydrogen cyanide is there. Cyanide is there. Any mercury salts. Mercury salts. Mercury salts. They are there. All these, they kill the activities of enzymes in the body. Activities of enzymes in the body are called inhibitors. So our next, we are still under types of chemical reaction. We have seen displacement reaction. We have seen catalytic reaction. The next one is a redox reaction. Redox reaction. So our next video will be number 3, which we call redox reaction. Redox reaction. Please like, share, comment, and subscribe. God will bless you as you do that. Thank you.